Things we're going to talk about Databricks and how to build a reliable data lakehouse, right? And we're talking about what a data lakehouse is versus what a data warehouse is, and how Databricks invented these whole things. So, yeah, if you don't mind, we can get started on this whole thing.
All right, excellent. Let's
Let's
get
go
the
ahead and
screen sharing started.
show the slides, right?
Now, I need sharing capability from Su Cheng. Su Cheng,
Okay.
can you allow us to share our screen? While we're waiting to be able to share the screen, I don't know about you, but I'd rather live in a lake house than a warehouse. So looking forward to the
I
distinction
love that.
between data lake house and data warehouse.
I love that. Yeah, well, that was the old. That's what the world was 10 years
Yeah,
ago, right? You remember that? And the whole world was you had a SQL server, you put everything in your lake house, or excuse me, in your warehouse, right? And you built your star schema from that, and you built your Power BI on top of that,
hmm
and it was nice and easy, right? It's pre AI, right?
yes.
So but all that machine learning started coming into it, and that's what happened here. So yeah, I can't wait to show you. It's all a part of the presentation. That was a preview right there.
Awesome. Yeah, well, I'm excited because again, we're ultimately going to model all of this. So
Yeah,
having a structure that is more amicable to modeling is kind of what we care about.
that's what we're gonna talk about. Yeah.
So very cool. All right, let's get this going here. Slideshow, we can start from the beginning. All right, take it away, Bill.
All right, everybody. Thank you for taking the time to listen to me speak.
Record the talk. Sorry about
What's up?
Would you like to record the talk?
Yeah, sure.
Should we start record? You understand?
Okay, we're good to go. We've passed clearance, everybody. We've made it. So again, we're just going to talk about the data lakehouse structure and how to make it reliable, things that I've learned. And so, by the way, when we go through this talk, and this is a little bit of information on you. You can scan the QR code right here to get information about me and connect me on LinkedIn. I've been in data engineering for about 5 or 6 years, worked at several different places, did some consulting. I'm a let's minimize this. Oh, we lost our slides, guys. There we go. I've been, like I said, data engineer 5 or 6 years. Like I said, I'm a Buffalo Bills fan. So if anyone's from Buffalo, probably not in this room. I know I went to a TP meeting and there was a Bills fan speaking. So it does happen. I've been to all 50 states in the U.S. and Canada. I have not been outside of the continent though. So not as exciting as that seems. And as far as pets, I do have a black cat. With that being said, we'll get into the presentation. So what we're going to talk about today is we're going to talk about data lakehouse. We're going to talk about the overall design of how you should build this. We're going to talk about medallion architecture. You hear that a lot. The bronze, the silver, the gold layer. Then we're going to talk about what I think is important is a metadata approach. How do you make this scalable? How do you make this opportunity where you can sit there and kind of scroll through different things and make it easier for you to solve problems easier? We'll talk about a common data model, which is kind of like your star schema or maybe your snowflake schema as we go into that. We'll talk about the use cases. So when do you use pandas or Spark or SQL? There is a different reason for using different tools. We'll talk about some validation checks because, as you know, there are problems with data. As there are problems with data, we need to have a way to solve these problems. And then we'll talk about some security best practices. With all that being said, I'll kind of start moving through the slides. So as you start building your data lakehouse, and this is what I've learned, right? So I've worked with different companies and seen different problems in this world. And a lot of times people just want to kind of go in and the executives want to just build something, right? Just give me a Power BI dashboard and just give me some AI. That's what I care about. I don't care about this other stuff. And the problem is you have to have a plan, right? You have to kind of know what you're doing, what you're bringing in, what the different sources are. You have to have buy-in from the executive team because without that, you really aren't going to have a solution. So what we're going to kind of show you in this slide deck is kind of certain things to explain to the executive team so that they understand what you're going through and your pain points in a simple way that they will understand, right? But as we know, as we build these things out, things are going to change. We have to have an agile structure. We have to have a feedback loop where we're talking to the business and getting their input as we're building. Otherwise, we can't have a waterfall approach that's not going to be usually very successful. And as we build, most of us developers don't document things well, which we actually should because 2 years down the road, you're going to forget everything you built. So have good documentation with what you're doing, especially with diagrams and such, right? So, like I said, the big issues with data is, putting quality data forward, right? Garbage in, garbage out. If your data is not good, it's not clean, you're not going to have a good warehouse, right? So if your initial bronze layer, which you bring the raw data in, is corrupted somehow, and I've seen that and I've worked with that in the past, you're not going to have a good silver layer or gold layer because it's all downstream from that. Your naming conventions, agreeing on a naming convention and understandable language. This is also important when we come to AI. And the reason for that is you want a naming convention that's understandable and readable, where a human can understand it. If they just walked in today, they can see your column names and it makes sense to them. And that's going to help you with the AI focus down later, right? Because the machine doesn't understand AI 342 as a column name. If you've ever seen Great Plains, you can't have confusing column names because it's not going to make any sense to the machine. So you want to think about that and have clean names. We'll talk about least privilege access, which means only giving people access to what they need and nothing more. And then we'll talk about building automated testing in the process. Why does this all matter? Good model design increases speed delivery. And honestly, in working with lots of clients, what they'll do is they'll build something really, really fast, and then it doesn't work. And they spend months and months and months trying to verify the data and making sure it works. So that's always an issue. Like I said, lack of planning is ultimately going to increase your cost down the road. Poor design increases your security risk, and we'll talk about that as we go later into this presentation. Again, if you're doing things with best practice, you're sure trust. You want to make sure your data is clean, understandable, that everybody understands it from day one. Because if the business users don't understand, you can build the most beautiful dashboards, the greatest models, but you need an end user to use it, or else you've kind of built nothing that's purposeful, right? So that's super important. Like I said, obviously, when you build a well-architected database, it all starts with a solid foundation, and that's, of course, your bronze layer, and that we're going to talk about. Common fails is your data lake. You don't want it to be a swamp. So you see this picture, it just kind of looks like my children's bedroom, right? And what this equates to in the real world here is when you start bringing data in, right? If you're not planning it, you're just kind of, we'll bring our Salesforce stuff and maybe we'll get some Google data here. And you just kind of start bringing stuff willy-nilly all over the place and don't have a plan. It kind of looks like this picture right here. This is kind of something we want to kind of avoid in the real world because you'll have what we call a data swamp, right? Like I said, another issue that I've seen in the past is, the security features are kind of added after the fact. So you build something and it works and it's great, but you put everything as public and you didn't have, MFA is not set up and things are, and it becomes a lot more challenging after the fact to fix these kind of things. Okay. Obviously, if you do things wrong, you have high costs. How do you sit there, especially when you work with Databricks? How do you understand what compute to use, when and where? That's important because if you don't, you can spend a lot of money, especially in the cloud. The on-premise is always generally cheaper than the cloud, right? And if you do things wrong in the cloud, you can sit there and over provision too much compute, and you have your bills are astronomical. So in the planning phase, think about those kind of things and explain those kind of things to management because you can regret that. Your CFO can be pretty upset with you. Again, of course, user confidence, making sure that their data is accurate and correct. And like I said, the rework and the product fails. Like I said, I've seen so many companies that will do something wrong. They'll try to somehow continually add on to things, even though they know that their data lakehouse is incorrect. They continue to do something, and it just makes it worse and worse and worse. So you can't do the rework is what's going to kill you. You can do something fast and wrong, and you will then realize it's fast and wrong, and then have to redo the entire thing. And then you end up redoing it, which then wastes a lot of time and a lot of resources and costs a lot of money. So these are all things we want to avoid. So when talking to management, I like to use this data pyramid right here. And I find this really, really useful because you have to understand the foundation we're doing, right? Obviously, what we're doing first, we're bringing data in, and everyone understands that piece. Then, of course, you have the ETL tools where you're going to manipulate that, and people kind of get that. But this purple line right here where it says master data management and governance, this is what gets lost behind, right? If you don't put your data in correctly, and you have say you're bringing a couple different payroll sources and merging them together, and you haven't really come up with a plan to make everything balance out, right? You haven't checked that stuff, you're going to have a mess. Usually the biggest problem with data warehouses and data lakehouses is the data ultimately, right? Is it correct? Is it accurate? If this isn't right here, don't move to the next step. Everybody, the executives are going to care about the data science, the AI, and that's fun. They care about the dashboards, especially in the past. And so that's what they always want to focus on. However, without the foundation, it's not going to work, right? So the top two layers kind of almost can be done in parallel. You can have maybe a data science team building some of your AI models, right? And you can be building dashboards in Power BI or Tableau with a different group. So both of those work fine. It kind of can be done in parallel. But these first three layers are not done properly. The top two are a waste of your time. It will not work, and you'll be doing rework, as we talked about before. All right. So when we talk about a data warehouse and a data lakehouse, what's this? So in Databricks coined the term data lakehouse, right? And so the key is if you start looking at it from this side over here, this is a traditional data warehouse, right? You had all this different data you ingested in. It goes in this big SQL Server, generally data warehouse, right? It's nice and clean. It's all in one place. And then you put your reporting tools, right? You may have paginated reports in like an SSRS type tool. You may have, your dashboards in a Power BI or a Tableau or a Click. That's pretty much the standard process, right? And that worked in the 80s and the 90s and 2000. And then we got a little bit smarter. We started getting into predictive analytics and machine learning, all those other fun things. So then what happened is you got to a data lake, which is kind of where the swamp came from, right? So you have your traditional, as you can see right here, this is your traditional data warehouse, okay? Looks exactly the same here as what you see right here. But then, we decided to sit there and add more data. As you can see right now, instead of just having structured, clean, tabular format like in a SQL format, we then had unstructured data, semi-structured data, pictures, images, JSON files, right? So you're starting to bring all this stuff in there. They're kind of being used separately. Your structured stuff stays in your SQL database. That's traditional. But now, you maybe have a Jupyter notebook on the side that you're doing some kind of data science stuff in, right? With some machine learning. So it's kind of almost like two separate streams, right? And so Databricks, like I said, they coined this and they decided to put everything in the same place. So what you'll see here is this is a data lake house where all your data is coming in. It's going into one place and being governed in one place. And this one place is being governed in the Databricks world is called the unique catalog. And Snowflake has its version as well, but in Databricks, it's the unique catalog. And everything goes in this one layer. It's kind of like a file structure where all your data is nicely, cleanly organized. And from there, then you can get your dashboards. You can get all your reports. If you want to do any machine learning or AI or anything like that, that's where it comes in. So this is kind of what we're talking about. So we're talking about this piece right here and how to build this piece right here. Okay? With that being said, so when we talk about doing this, how do we build? We talk about a medallion architecture. What is a medallion architecture, right? It's as simple as this, right? You have raw data. That's what you're getting from your initial source, whether it be a Google API, whether it be Oracle or SQL, right? It can be anything. Okay, you can connect to Salesforce. So that's what you're going to bring in, and that goes into your bronze layer. And this is going to be that raw data. It could be JSON or anything that you brought in, but it's going to be structured. So now it's going to be more in that SQL format. So again, we're kind of talking about how the warehouse works, right? Then from there, we're going to start putting business logic rules. We're going to start merging tables together, joining things, right? Instead of having a very, very normalized structured data that you generally get in a traditional transactional database, we're going to sit there and make it a little more denormalized, so it's a little bit cleaner and easier to work into our Power BI. So it's cleansed at this point. And then the next spot is we're going to go to that gold layer. The gold layer is interesting because this is the layer that you're going to start sending reports out. So this is going to be a little bit more aggregated, right? Summed up counts and stuff like that you can start working with. And this is where everything fun comes out of it. And this is where if you've done it correctly, you're going to get to that gold layer. And as you'll see, the gold layer is not just this massive data warehouse. The silver layer is going to be much more of a data warehouse, but this gold layer is going to be like kind of data marts, right? So your marketing team may have their own layer, and your HR team may have their own layer, right? And so all these different business teams may have their own individual layer for their own individual purpose. And when we go further, you'll see this is going to help your security because I can sit there and make sure that they never see the bronze layer or the silver layer. They only see their particular data mart for their particular stuff. So again, there's not a security issue going forward. So going down and getting a little bit more granular into what this really looks like. This diagram right here is going to show you all the different potential data sets that you can bring into this whole thing, right? So, perhaps you have an Excel file. Everyone has a SQL server of some sort, right? Facebook's coming in there. You have an ERP system or a CRM system like Salesforce. So that's all coming. It's all being ingested in. And so, like I said, what we're going to start showing is how we're going to ingest this in. So we're going to use a control table, right, as we start building this out. And that's what we're going to talk about kind of next, is that we're going to have this control table, right, that's going to go in there and loop through things, as opposed to having like Data Factory, you just kind of bring things as you're going and it's kind of willy-nilly, which is what we want to avoid. We're going to have a nice control table to keep it nice and clean. We're going to set up logs, right, so if we do have failures, we know where they are. We can go back and easily fix them and find them. Like I said, when we organize this, we're going to organize this initially by the different source systems. So each schema that we're bringing in, so in Databricks, it's a 3-level namespace. You have your catalog, right, which in this case might be dev bronze, right, or test bronze, or prod bronze, right? That's our catalog in Databricks world. Our next namespace is going to be the schema, right? Which this could be, in this situation, Facebook. It could be Salesforce. It could be Google, right? The sources that we're bringing in. And then, of course, your table name is your third namespace piece. Like I said, we're also going to bring in a lot of, as you're familiar with data warehouses, a lot of stuff you kind of bring in kind of ad hoc. So you'll have like a date table, right? Because every data warehouse in the universe needs a date table. You may have a table that is dealing with locations or zip code to, county type things like that. So you can use that as well. Like I said, and again, Databricks, like I said, when it says create volume for manual imports, right? In the Databricks world, that is kind of like connecting a directory in your blob storage or your S3 bucket, and that's what you're connecting to grab that data. It's external data living somewhere else. Right. So what does this look like? So here's our control table. This is an example of what you would do with Google, okay? And so what I'm trying to show you here is that over here, what you'll see is this is the destination table. This is what we're going to put it into. So as you see, it's a 3-level namespace. We're calling this development. And then, our sources, again, Google. So that's what we're using. We're creating 2 different tables, events and users. Okay, that's pretty standard. And then what we're going to do, and I'll show you in the next few slides how this is going to work, is we're going to bring in our parameters that we actually plug into our API call, right? And so you can see right here, we use dims, mets, limits, right, offsets. These all get plugged into my API call, and you'll see how we're going to loop through this to pull this stuff and call that API and grab that API and put it in these particular tables. And then, our load type, do we want to do incremental, full, are we appending? There's different ways, and it depends on what you're trying to do. Sometimes it's easier just to do a full refresh, just truncate your data and put it back in. If it's small amounts of data, there's no reason to sit there and constantly, try to find an incremental when there's only 2 records you're adding to it. It's small data, but most of the time you're probably going to use an incremental refresh. So this is, like I said, a control table. This would live in potentially an Excel file. It could be in a table in SQL. But essentially, this is what you're going to go to. You're going to collect this information in sort of kind of a data frame and kind of loop through it piece by piece. Okay? And so this is what it looks like from a code perspective. Okay? What are we actually doing here? So what you just saw, this config df, this is going out there and it's looking for everything that's active is true, but it's looking for base that table you just saw. It's going to pull everything in from that table. Okay? In the Google perspective, we kind of hard coded this, but we have a start date and end date, and this is how we're creating a date range. Again, the days back 7 could be in that table, and we can get it as a parameter and then add it in here. Okay, but as you can see, we're looping through this. So this is just a for loop inside that table, right? And collect essentially takes a data frame and allows you to go piece by piece through it. So you're collecting your catalog, your schema, your table, as we talked about. Which is you're going to put together to create one long string. So you use an F string right here to create your 3-part namespace. You're collecting those dims, those mets, off, all these different parameters that we had just talked about. The load type we're collecting, right? And so, sorry, I'm going to go back a slide. Sorry. So let me get this off our screen. As you can see right here, this is the request. So now I've pulled all my different stuff. And again, this is in the same for loop. You probably can't tell because it's put to the side. But now I'm taking everything and plugging it in here. So I'm making one request out there for the events table or the users table, and I'm looping through that, right? So here's how I build the parameter, and right here, the response this is where I call the actual API. And again, we're simplifying this. There are tokens behind this, and you just can't run this code. It's going to work. We're going to be a very simplified thing, but you're going to call it. It's going to give you some JSON data. It's going to come back in, right? From that JSON data, we're going to take it. We're creating a data frame from it. So we're going to take that JSON, reorganize it, and build it into a data frame. And then from there, this is where we take it and we load it. So we have another function that's built out here. Again, this code won't run directly because other functions are built, but it's going to load that data directly into your data warehouse. All right, so now that it's loaded your data warehouse, what's the next step, right? So you have these bronze layers, like I said, Facebook, Google, all these different things, right? So that was a Google, so there'd be a Google bronze layer. Now I'm going to start merging everything into this one huge data warehouse, right, where everything lives. And this is, like I said, one big data warehouse. All tables are going to be in nice tabular format at this point, and they already kind of were prior to that. This is where your data types are going to be assigned. So if you just brought things into strings, now you can make them your integers, your floats, your decimals, whatever you're going to do with that. We can start creating fact tables and dimensional tables, which we'll talk about in the star schema as we go forward in this presentation. And again, at these two layers right here, the focus is this should be what the developers and the administrators still have access to. This is not something that we need to give everyone access to because it's too complicated and confusing for the business user. They don't need it. We want to simplify that for them in a gold layer. So again, how are we doing this? How are we creating that next layer? What we're going to do, again, we have another control table. I didn't show you the control table, so just imagine this with me. We're going out there, and there's a control table, and it has a couple things. It's going to have, again, it's where's my source tables? Where's my destination tables? It's going to say what kind of execution type is it going to be? Are we overwriting the data? Is it slowly changing dimension? Is it incremental? What are we going to do with this data? So that's what the execution pipeline is, right? So I'm taking that and just kind of, again, looping through this stuff. All right. I'm creating a list of all these different things. So now, like I said, just like we did before, we found that data, we found that information, and now we're collecting that information to loop through. And then again, now that we have that information in one data frame essentially, or one list, we can then call it here. And I'm going to kind of go deeper into this. Again, we're passing it to this function. This function is picking up the table name, and it's picking out the execution path. The execution paths are right here. And so now we're going to run this notebook, which is going to then run another notebook. It's going to decide if it's an incremental or an overwrite or something to that effect. Obviously, there's a timeout right here, and it's going to pass in the arguments. So what you start doing at this next level is you're running your Python scripts or your SQL scripts, right? So you have a whole bunch of different tables independent of each other. And this is what's going to make it easier when you have to fix things because they're all independent of each other. They're all kind of their own separate thing. So as you see right here, we're able to pass parameters inside of our functions, inside of what we're doing here. And like I said, we have a bronze catalog or a silver catalog. And again, in our different environments, this will change because in our dev environment, obviously dev, bronze, for example, dev, silver, etc. And then when you go to the test or prod, it's going to be prod, bronze, or prod, silver, etc. So it's going to change as we kind of move through this thing. But this is how you're parameterizing it. So again, what you're putting out there, all these different tables you're building are going to be separate files that you're going to kind of loop through and run through, right? You're going to also have an order for these things as well. So like your dimensional tables will probably get run first. You may put like a 100 code there. Your fact tables may come later, then maybe a 200, and then maybe something you're building thereafter, maybe a 300. So again, you're going to pick those things so you can find them and then run them in parallel to create your files. So with that being said, this is kind of how you're executing this, right? So as you look at your Python code, what we're doing here is simple. Like I said, we have all these files kind of stored out there, SQL files, Python files. Again, the SQL files we're going to look at, this open files right here, all this is doing is picking the file up as if it was a text file, right? It's the file we just saw on the previous slide, right? And from there, this formatted SQL template format, all this is doing is taking those parameters, those global parameters that we just plugged in, and passing it into it. So now we know what dev bronze is or silver bronze is or any other kind of information, right? We're seeing it. It's now plugged in there. So now you're picking that up. So now you have that text file, and now you have an actual query that actually runs, right? And so again, we're creating a path name. But this right here, the Spark SQL at the bottom, this is the magic. This is what's running the parameterized statement. So it's coming back and says, I'm going to create or replace this table as what I just showed you, with the actual SQL filtered in there. And that's what's going to run the entire thing. And of course, create your data frame, which you can then pass into your file. So this is the same thing if you were doing from a Python perspective. Again, kind of simple. The command to actually run Python is, again, you're picking your code, clean code, and then you put either a global scope or a local scope. In this situation, we're using all global scopes to put in there because everything is going to be that bronze layer, that silver layer, whatever that we're putting in there. So as you can see right down here, like I said, we're picking the file up as if it were a text file. We're then adding the information into it, and then we're running it, and then we're creating the final data frame. Now, the key with using this is that when you build this out, you can't use any kind of pip install. That can't be a part of this at all. It won't work. And you also have to make sure that when you create your data frame, it's always called final df. And once you do that, that will create your final data frame, which will then allow you to insert that into what you're doing. Okay. So what we're building here, like I said, we want to build a star scheme. If you're not familiar with the star scheme, this is kind of what it looks like. Your dimensional tables are kind of like your reference tables, right? So this is going to be like, your product table, your date table. These are all kind of lookups in what you're doing here. And that's going to join to your fact table, and your fact table generally is going to be kind of your aggregated sums and values that you're using. So again, that's how you build it. If you need to create kind of bridge tables, this is kind of used when you have like a many-to-many relationship. If you've ever seen survey data and work with that, a lot of the data that you will see in survey data will have like multi-select. So you can't just join it to your dimensional table from your fact table because it'll be a many-to-many relationship and will cause problems. So you might have a bridge table kind of in the center of that table. Okay, and of course, when you're building this, you want to make sure you have integer IDs. Those IDs will help connect, and that's going to reduce and compress your data, right? All right, so now that we have all this stuff built out, now we get to the fun layer right here. This is where we're going to start putting all of our data into our different marts. So you have your data warehouse right here, and now you're putting in all these different marts right here. So marketing or sales or accounting, human resources, whatever it may be, right? And when we do this, here's the key to the whole thing: is this is your opportunity to kind of aggregate things out. If you have a lot of financial data, it's like millions of records. It does make sense to sum those up by perhaps GL code. You don't have to have it at that granularity if the business doesn't want that kind of granularity. Okay, so when you start working at this level, again, we have a data warehouse that has all the information. We can create views and materialize views. Okay, and views are going to be for smaller data sets, right? You know, a lot of your dimensional tables are small. They're like 100 records. You don't need to store that anywhere. You can just, create a view just to find the information to look at it. Your fact tables are generally be larger. And so rule of thumb is probably you want to use like a materialized view when you have 500,000 records or more, or something that's super complicated that takes a lot of time to run, because the more information you have to run, like if that query were to take, 30 seconds to run, that's a query you want to materialize view, because you want that to continue to incrementally pull that data through, right? If the query runs in like a millisecond, it's a great choice for a view, right? And this is just making your data smarter and working better. Like I said, it's now isolated, and the beauty of it being isolated is the fact that now you have security of each individual piece that you're working with. Okay, and so everybody kind of loves to use Spark and these different things. I'm not going to talk about every little piece inside of this. You can take a picture if you're interested in all the different details here. But I have noticed that there is an advantage to using pandas, even though most data engineers will say use Spark for everything. When I've called APIs, especially like Facebook or Google or something like that are single-threaded, it doesn't make sense to sit there and bring in Spark for a single-threaded approach. If I have to sit there and call every single post that I have for Facebook and loop through hundreds of posts and then kind of union them together as I'm going in one big data frame to then insert into my final table, a Spark data frame it almost takes longer to run. So there are advantages sometimes to actually just running things in pandas. Again, if it's a smaller data set and it all fits into a single threaded, then use Spark. Obviously, use pandas, excuse me. In a Spark world, this is going to be when you have big data and you want to run things in parallel. That's when Spark makes sense. And you also want to make sure you optimize Spark so it actually works well. Now, SQL is also great. I mean, like I said, if you run Spark and you run Spark SQL, you can actually write SQL into your Spark, right? It kind of works the same way. But once you have your data kind of in this beautiful relational database, right, then it almost makes sense just to write SQL code as you're doing a whole bunch of joins, because Spark is kind of clumsy with all these little dot this and dot that as you're building it through. So at that point, once you have structured data, SQL has always been what we've used in the past. Stick with SQL. These are some smart optimizations, and we can talk about Spark all day long, but things that you want to avoid is the collect statement. The collect statement is generally when you're trying to take that data frame and break it into row by row and kind of go through it row by row. That's generally something I would rather just do in pandas. Because again, if I'm using it row by row, it's probably a small data frame, because that would cause a problem. User-defined functions are also something that even in Databricks world, and even in their documentation, they will tell you to avoid. So user-defined, you want to find a better solution generally for that. And like I said, when you're setting up Databricks, like I said, you do want to set up predictive optimization, and that gives you a lot of different features that are beneficial to you. It does create liquid clustering, which allows your partitions to be equally set up, as opposed to allowing a partition to be really, really large for some and then smaller for others, allowing skew. So like I said, that's one thing you want to pay attention to when you're building this in Databricks. Another thing you don't want to do, again, when you're using Spark especially, you don't want to do a select distinct. that kind of kills any opportunity for parallelism. So now you're running it single threaded. If it's single threaded, it's not going to give you that parallel processing that Spark is good for. Using broadcast joins, again, this is a Spark thing, makes sense, and that's to prevent shuffle. So if you think about having all these individual partitions, you have small files. You kind of want to just sit there and put that small file in every single individual partition as you're joining things together, because it's going to make things much more efficient, allow it to run faster. Obviously, all tables are going to be Delta tables. That's built into Databricks. Iceberg is the format for a lot of Snowflake, but they all kind of work about the same. From a data perspective, we talked about cost earlier. Serverless cost is what makes the most sense in a production environment. Or, like I said, if you're building automated process, you can use job computes. But what I want everyone to kind of know and avoid is using those all-purpose clusters. Those all-purpose clusters are great as you're working with groups and you're trying to work together to work on different things. But those all-purpose clusters are expensive. They are the most expensive kind of compute. And so in the production environment, you want to avoid those, right? Obviously, the last piece is watching for that data skew and poor partitioning. Again, when you're trying to run your Spark, you want the partitions to be as even as possible to the best of your ability. Because what you don't want is it to have a bunch of really small partitions, one massive partition. And so then everything runs really, really fast, except for that last partition that's taking 10 minutes to run, 20 minutes or an hour to run. And so that's why you're trying to make sure that you have even partitions as much as you possibly can have. So another thing we want to talk about how do we create data and how do we make it clean and how do we sit there and find ways to make sure you have quality checks throughout the process. And you'll hear the word shift left, which means try to find the quality issues in the bronze layer before it goes to the silver layer, and then try to find them again in the silver layer before it goes to the gold layer. So you're always trying to find them as much as possible. This is actually directly from the Databricks website. I just kind of copy and paste it. And it's really not that complicated. So you're initiating a generator, and then you're going to have some kind of a file out here. In this case, it's called customers.yaml. So it's going to be a YAML file. I'll show you in the next slide. That is going to kind of create these different rules that you can use to find these issues. All right. So again, a lot of this is boilerplate. I just wanted to highlight the points that you would actually care about when you're building this. Is when you're building it, like I said, you're going to put your table name in there. Maybe what column I'm looking for. So I'm saying order ID has to be a string. There's my data type. I'm also telling that there's some regulars right here. It's got to be ORD and then some numbers after it, right? So you can kind of build these different things in here. And this is going to kind of check to see if you have errors in there, right? If you want it to be, a value couldn't be greater than 1,000, that's something you want to check for, right? So there's all these different things that you could possibly check for. And this is going to prevent the problems from happening. So at least you can log those problems and identify them and fix them before they go too deep. Because if you don't find these things, somebody will eventually find them, and if the business finds it, then they're yelling at you. If QA people find it, then they're yelling at you. These are just things to try to prevent these from happening. And again, this is DQX, which is a Databricks thing. There are other tools like Great Expectations you may find out there. There are several different tools that are out there that are able to do these kind of checks. This is kind of the one that Databricks uses internally. So security best practices. Obviously, the rule of least privileges makes sense, and we talked about that earlier with creating those different data marts. Obviously, never store passwords or tokens directly in a notebook. That should be in a key vault if you're using Azure, but it always should be stored somewhere else where you pull it in there and then you can't see it. Unity Catalog in the Databricks environment, that's where everything lives. That's where everything is pulled together in this nice world. This is where all your volumes live, your machine learning, everything's in one spot. It looks like a nice file directory. That makes a lot of sense. It also lineage is also built into Unity Catalog, so you can actually follow along and see the path where the original file came in, then it was transformed, then it was maybe transformed again. You can follow that. Again, build audit tables because you want to know when things fail. You want to know where they fail. You want to be able to go easily back to those tables so you can go back to them and make your changes quickly. You also want to use it for watermarking if you're doing incremental loads, so you can sit there and know when something ran, so you can then run the new incremental after that watermark date. More best practices, and these are pretty obvious here. Multi-factor authentication should be a given for anybody nowadays. Each environment, like I said, should be its own instance. If we have a dev, a prod, a staging, whatever, those are their own instance of Databricks. They're completely isolated from each other. So if you mess up your dev stuff, that's okay. It doesn't hurt your production data. You're going to set up permissions by group. So usually in your intra, and if you're using Azure, you could set up, a marketing team or an HR team and then set up the permissions there. That way, when somebody leaves or quits, you can take them. You don't set them up by individual user. In Databricks or even in Snowflake or a lot of these different warehouses nowadays, you want to use delta sharing as opposed to just copying files. It's not a good idea to copy a file and email it to somebody. So using kind of a sharing thing where you can actually control it and give somebody access to your data makes sense. You can also remove access if there's a problem. And obviously, if you have restricted data, you want to make sure that you're using row level security to restrict people. If you have a sales team and people are seeing data from Canada or US or Mexico, you can sit there and filter that just to USA, so they only see the data that's interesting to them. Pay attention to PII. You may have PII where it has somebody's birthday or their social security number or an address. You can create a function in Databricks that essentially, if you're not an administrator or not a certain group, that it may be just a bunch of X's. So you don't see that data at all, and it prevents you from doing anything harmful. And a couple of key takeaways from this whole thing. This is kind of where we're going to kind of wrap up in a moment. Like I said, better architecture is going to allow for better security, obviously lower cost because you're not doing a ton of rework, faster delivery time because you don't have all that rework again, better data quality, and better user confidence for our end users. So that being said, does anyone have any questions?
I know Sovereign is going to be more expensive than on-premise. Is there a trade-off there?
There kind of is. I mean, you can set up anything to turn off, right? So yeah, you're actually absolutely right. Like you do want to set things up. Like so, if you're using all-purpose compute, you can set it up. If you're not using it for an hour, to turn off, right? You use it for 5 minutes, you can turn it off, right? It's all those different DPUs. Generally, when we're getting to a production environment, we're putting it as a job compute, right? So job compute's going to run, and once it finishes doing what it's going to do, it's just going to turn off automatically.
Recently, I heard about something called data factor, which is maybe supposed to be more powerful than this. How would you like other workflow? Talk about Fabric architecture.
Yeah, so Fabric is the Microsoft version of Databricks. So it kind of does the same thing. They have the same notebooks in there. They have the same data warehouse in there. It is a lake house. Fabric came from Synapse, was the original product, and they kind of took Synapse, made it a little bit better, put some AI on there, and then added kind of Power BI into the mix. And so Fabric includes everything. You can do everything in Fabric. So it depends on what you prefer. You could use Databricks, you could use Snowflake, you could use Fabric. They're all lake houses. Yeah.
Do you have any comments on time series data?
Time series data? I haven't worked done with time series data, so I don't have tons of comments about that.
It's kind of a tough topic.
Yeah, like IoT and stuff like that.
Sure, financial applications, IoT for sure.
Like streaming type architecture. That would be
just indexing. There's a lot of hacks, but
yeah.
to do this correctly. But I like your talk, so I was wondering if I had much experience with that. That's fine if not.
No, not a ton. Like I said, I know it's you're definitely doing all the streaming type stuff like that, and that's there's streaming table you can build in Databricks or build in these other environments, and there's different ways that it's done. And I know it's like micro batching sort of, so you collect data for 5 minutes and then you put it into your data. There's a feature actually I think it's kind of fun in Databricks called autoloader. So say you have like millions of different files you're streaming in, you can actually put them into your blob storage, your S3 bucket, whatever. And as the file comes in, it picks it up and puts it into, it streams it, it puts it up and puts it into your database, right? So as you drop files there, it keeps on going. But what it does do is it knows the last file you've put in there, right? So it doesn't add it. If you put like duplicate arrays, it doesn't add that in, right? And then the cool thing about autoloader is it also has like schema evolution. So if you're say you have like 50 columns in a database and then you add 3 more, it will then know that and add it into it.
Yeah, I'm quite person, but I want to know.
You want to test me?
Yeah.
small demo to show this kind of stuff. Just first, for example, you have different rounds of gold data. Do you have just by chance any demo to show that? Or?
No, because the demo would also show an entire thing, which would be tons of memory, and then you'd probably be hacking into someone else's system, or well, here's my works data warehouse, and that's probably not gonna work.
So you go to the slide. I think you have slides explaining the data warehouse and data lake, something like that.
This right here. Yeah.
So what is the like ETL? What meaning of ETL?
Yeah, so that's extract, transform, and load. So nowadays it's kind of extract, load, and transform, right? Because I mean that bronze layer is essentially we're extracting data and we're loading it directly into our data warehouse, right? And so then we're going to then probably do the transformations into that silver layer. So ETL is we say it a lot, but it's kind of misleading. Because it's really extract, load, then transform. In the past, you used to do a bunch of manipulations before it got there, and so it was extract, and then you were extracting it and then doing a bunch of manipulations and then loading it because you didn't have all these different layers.
So here, for this example,
yeah,
it's basically the data lake is that you actually data science, this kind of people, you actually load the raw data, and then the data lake of this kind of architecture, you basically build a metadata layer across all the raw data.
That's exactly it. Because I mean, like what would happen in the past is, like I said, you generally had like a warehouse, right? So it's like your SQL, and then you would have like a data science team, a bunch of researchers, and they generally were working in something separately. Like they use a lot of like Jupyter notebooks. If you've gone to some of these companies, they'll use like a Jupyter notebook or Google Colab, and they're doing their own little thing. And that's how you have that lake house. So they may want to pull some structured data and augment what they have, right? So you'll see that kind of line right here, if you will. But you can kind of see it's like totally separate, So that's always been the problem is that when you have separate stuff, it's like, okay, they're using something on-prem, they're using like Jupyter Notebook, and we have this huge data warehouse, and then somebody quits and they don't know where it is, and notebooks are everywhere. At least in this environment, everything is there. So like when I was at NCSBN, they had everybody's working in SAS, somebody's working in SAS, and somebody's working in RStudio, and then somebody has some Jupyter notebooks, and all these different consultants doing their own different thing. And I was like, we need to get this all in one place, right? That's fine that you use, because it's the same technology. You're still going to use R or Python, or if you want to use Scala, you could, and you can do it in Databricks, but at least it's all in one spot, so we can easily find it because it's just there, right?
So basically, in the data lakehouse architecture, if the for example, data scientists try to access some particular data, which is not in the metadata is not in that layer, so they have to build that metadata layer for the data to process, and then the metadata will be stored, cached in that layer, so everybody can use something like that.
Yeah, I mean, you're still gonna collect the data and bring it in from wherever they're getting the data from, right? So again, like as you see right down here, this is where everything's coming from. It's going in here. So this is like unique catalog. It's probably wish I could look that up for you and show you, but a unique catalog essentially looks like a directory system, right? So if you've seen like Object Explorer in SQL, right, we have all the different tables in there, right? You can kind of click on it and it shows the columns and such, and so it's like your database and your schema and your table, and maybe you see the columns, right? And it just kind of shows you that hierarchy. It's the same thing, but then you also have like volumes, which are going to sit there connect to like actual blob storage. So you're seeing all of my tables, and then maybe I want to see images or something like that. It's all there in one spot.
So for production purposes, how would you have this like in a company, for example, when it comes to infrastructure, how would it be? Like, would this all be on one server, or would this be on multiple machines, or what kind of
You're probably going to build this in the cloud, right? So, like I said, it is going to be kind of separate, right? So, like your production is going to be separate from your dev and separate from your test, right? But yeah, generally speaking, in this day and age, everything's going to be Azure or AWS or Google, or possibly all of them potentially, and it's all filtering in. It depends on how they built it. Yeah, you can do a lot of ETL. Fivetran, if you Fivetran does a lot of things easy for you. Doesn't do everything, but like Fivetran, if you want to get Facebook or Google or something like that, it has a whole bunch of different connectors that are built in. You just pop it through. I know things like Salesforce, for example, or Dynamics 365. There are direct connectors that you can just easily just click your way through like a wizard and connect to. But then some of it you have to just write code.
Yeah, sure.
Like I was doing something with Facebook. We wanted to get like ad spend by individual age demographic information. And so Fivetran doesn't have a connector for that because you have to kind of loop through every single campaign that you have, and it takes every ad set and everything. So in doing that, you have to call each individual one, and Fivetran doesn't want to build something like that for you. So in a situation like that, you're kind of building what we saw here, where you're kind of looping through it. But yeah, there are easy ways to do it, but they do cost.
Yeah, I mean,
Yeah.
A lot of the tools that I've used for that, they're really powerful. And like just taking whatever data, just customize it, like mono
Right.
things. It's more just like it can just ingest tons of data. So
Yeah.
I'm finding that I don't like this. I'd rather. I hear what you're saying, like bronze layer. That's what you clean up and things like that. Sometimes there's a lot of stuff you gotta do long before it gets there.
Yeah, they're not a 1.5. I mean, like they do the easy.
Yeah.
Like if it, like a lot of your CRM systems, your ERP systems are generally databases behind the scenes anyway. So that goes really nicely with those kind of tools because it's just like data. But like when you have the more complex stuff and JSON and everything, like it doesn't work so nicely.
Yeah, and or like I work a lot of stuff that don't. They're just smaller things, and they just don't have.
Right. And then, yeah, they may have 500 connectors, but they only have 500 connectors to the big companies, the Fortune 500 companies, right? Like a lot of things you're not going to get a connector for. Like we were pulling government data from a website, an API. It was ecfr.gov, and so like there's obviously not a connector for that. We have to just go call that, right?
I have a request online. Maybe you could repeat the question from the audience. Because they cannot hear online.
Okay.
A second thing is any question in the chat.
There are in the chat.
No question. Oh, yeah.
Sometimes the table schema will change from this.
You cannot hear our questions if you want to ask them.
I like some of these questions in here. Let me look through this. I don't know. Work fast and break things. Yeah, that the idea of work. Somebody asked the question: in the world of work fast break things? These are tough sells. Yeah, that's true. So, yeah, yes, management always wants you to work fast and break things until it doesn't work, and then they blame you for it, right? Or you get in there and there's been like 3 consultant companies before you and they've broken everything, and then somehow you have 6 months to fix it. Yeah.
Okay, so Helen does have a question about what are the best practices to for those changes when the table schema are changed.
So sometimes the table schema were changed from the source data, multiple channels. In some cases, the schema was the same, but the data gets truncated. What is the best practice to prevent those changes? So, really, that takes a ton of proper planning. Did I lose this one? Yeah, I mean, I'm not sure how to answer this because the table schema is where it's changed from the source. Ideally, you want it to stay the same, but sometimes like a Fivetran or whatever will add like underscores because in like a Databricks world, everything has to be lowercase, right? So in the SQL world, you may have country code and it's capital C and capital C for code, or in a database world, maybe country all lowercase underscore code. So you would have those different schema evolutions. You kind of have to you bring the data in as you get it in the bronze layer. Then from the bronze layer, you kind of have to deal with what you're given. If that's the case, yeah. Ready to take over?
No,
No.
no. There's still questions. Then
We have one more question.
Okay.
So, your opinion, what kind of or data that you told me that where with this general AI time? So, what kind of change feel like?
Yeah, I mean, there's a couple.
what was the question?
Oh, yeah. So he was talking about what is going on with data engineers and data scientists now in the world of AI. It's really just more work for us. And then, again, that's where the data lakehouse is so important because, now you can take tons of documents, right? In the past, a bunch of PDFs didn't mean anything. We used to let people just read that stuff. And lawyers spend all day reading these things, and paralegals spend time. And now you can just put it into a regs model. You can embed it, and now you can ask questions to it. It's super easy. And that's where these warehouses come in. There's also a really fun tool. It's called Genie in Databricks. It's I think called Cortex in Snowflake that you can take your database and you can start talking to it in natural language and finding things. But again, when you do that, these are not the best tools in the world, right? You have to name your columns really well. You have to name it as if a human being, like this is a customer table. If you name your tables crazy stuff and you have your column names all over the place, it's not very effective. Because it's not going to know. It's because you're kind of telling it what it is. So it's usually kind of a semantic search to kind of match what you're saying to what's actually out there. So I don't know if that answer your question.
Yeah. I'm not in this area, but I'm curious about that.
It's a lot of things. I mean, you can do a ton of different things with it. I mean, I had one project where we took meeting notes, right? So NCSBN, which is the National Council of State Board of Nurses, they work with all the other different nursing boards, right? And so all the different nursing boards had their own meeting notes. So you can grab because it's Open Meeting Act, right? Anyone can grab it as public information. So you can take that API, you connect to it, you pull it. But they used to look for certain things, right? So for nursing education, they care about regulation, they care about like education, who was there, like different little things that were pretty consistent among the groups. And I could say, okay, if I'm looking for education information, what they've done, I want to see either the word education, program, college, university, different things like that. I can tell them that means what I'm looking for. And then I can say there's a structure that into a JSON file, and it would do that for me. And I can then scrape it into like a SQL file, and then I can compare different things, right? Because it's a PDF file. So then each meeting notes are always different from different states. They always structure, how it looks differently, but it's all the same content. So you can then take it and make it more unique. So that would probably be an example of something we couldn't do in the past because these things are all different. It would be kind of a pain unless we use like OCR or something.
All right. Well, let's give Bill a round of applause here.
Yeah.
And I think that about does it for this month's installment of PyData Miscellaneous Technology Meetup.
We made it.
Until next month, have a great time. If you have ideas for talks, if you've got some interesting things that you'd like to share, please reach out to the organizer team. We're always interested in looking at ways to share the work of the community and learn together. So yes, thanks for the applause, Justin. Not me, another Justin. And I think that's it. Have a great day, y'all. Thank you.
That was stuff for the pizza and drinks.
Yeah. That's what I came here for. The free pizza.
There's
That's what I
still
speak
some
for.
money.
The pizza now.
And happy Memorial Day.
Yeah, you too. You too. Thanks for we got to stream with them. So
So
we'll do that.